Now we will verify phase A and phase B high side signals. Yes, that's perfect. We can see when this channel A is high and it is reaching to this portion, that is around 120 degree, that time channel B is starting. A high, B low, C high. Then it will change C side. Yes, C is now changed. Then B is changed, high. Then A will change here. Yes. Then C will change here. Yes. Then B will change here. Yes, now A will change here. Yes. So our phase sequence is now good. Friends, welcome back to my channel. In this session, I am writing the code for this three-phase signal generator. Three-phase signal, we can take high side signal with 120 degree phase difference, or we can use UVW signal, high side, low side, similar as we need UVW signal in compressors, in different three-phase drive motors. We will utilize this code to build UVW driver kit for testing compressors and three-phase motors. Let's start. To write the code properly, first we will analyze three-phase signal combination. What is the relationship in the phases? Phase A, first phase, we know any sine signal, it have 360 degree. From 0, positive peak, 180, negative peak, then again 360 or 0 degree. This is first phase. And if we see second phase, it will start when the first phase will reach at 120 degree. It is zero line. This phase is starting here. Then it will go to high, then low. Its zero cross will occur when this first phase is at 120 degree. That means if we draw it back, it is in negative side. It is starting from 0. At that time it is at minus 240 degree. When this phase will reach at positive peak 120 degree, 120 degree, this phase will start from 0, from here. This is our third phase. At 120 degree, it is starting to high. So this is phase rotation. When first phase reached at 120 degree, here we can see it is 0 and now it is 120 degree. When second phase will reach at 120 degree, at that time phase C will start at 0. Here it is 240 degree. This is at 120 degree because it have 120 degree lagging. Because it have 120 degree lag from phase A. Each phase is lagging 120 degree. And if we see position of phase C, when phase A is at 0, if we will draw in the reverse direction, we will analyze different positions at 0 degree. Then we will draw these lines here. This is zero line. This zero line for phase B and this for phase A. We can use this project for any three-phase motors. Now if we start to analyze, we will monitor each zero crossing. Now if we see, we have this point here. What is that condition? When phase A is at 60 degree, phase C is crossing. Then at 120 degree, phase B is crossing. After that, if we check this zero cross, it is at 180 degree. Then the next cross, that is at this position, 240 degree. And then this cross, it is at 300 degree. Then it will return back to its basic condition, that is this one, that is 0 or 360 degree. When it is at 0, phase B is at 240 degree, phase C is same at 120 degree. So we can say we have these positions, so we will use these conditions in the software. Now we have two different ways. If we want to use one pulse like this, second pulse will start from here, then this pulse, this is one condition. We will use only one peak, positive peak, 1, 2, 3. We need 3 outputs from Arduino Uno. But if you want to use it in push-pull condition, this signal can be obtained by one transistor, one switching device. So we need 3 signals, first, second, third, 3 signals to be injected to these transistors so we can receive this high-low. But if we are using UVW signal, what is that? That is positive, then this signal. It will become like this. Then the next signal, when it will reach at 120 degree, this signal will start, and so we need 2 type of drives, high drive and low drive. When it will reach at 120 degree, phase C will on. So we need 2 signals, one here high, low, 2 signals for this condition, 1 signal for this condition, this or this. Let's make this signal at 0 degree. When timer is starting, T0, at T0 we can say A high, A low, B high, B low, C high, C low. We have A high, A low. B high, B low, C high, C low. We have 6 signals. We need 6 signals. Similar here, if you will see here, at 0 degree, A high is high, A high will go high. At that time, A low is low. B high, this signal will remain low, but B low will high. When it will high, this transistor will switch and it will provide this voltage from negative side. C high will high, C low will low. When timer will reach at 60 degree, we will provide time T1, that is 60 degree. At 60 degree, these signals will remain same, just only this signal will change its position. C high will become low and C low will go high. We will divide this sine wave in different positions. 1 portion, 2, 3, 4, 5, 6. So this time period will be divided in 6 portions and each portion will give time delay. T2, when we have second time, at that time B low will come low, but at that time B high will go high. That is this position. After that, the next condition, that is phase A, T3, 180 degree. This is 120 degree. At 180 degree, A high, it was high, now this signal will come low and A low will become high. Other signals will remain same. Then at 240 degree, that is this condition, at this condition our C low, that was high, now it will become low. T4, 240 degree, all positions will remain same. C high will go high, C low will go low. Then at 300 degree, that is this position, T5, we need B high low, B high low, B low will active. Then T6, at time 6, A low become low, at that time A high will become high and it will loop back to this position. So this is program structure, how we will generate time from here to here, how much frequency we need. For example, we need 50 Hertz minimum. Total time for one complete cycle, 1 over F. 1 over F, 50 Hertz, it is 20 millisecond time. Multiply with 1000, 20 millisecond, multiply with 1000 to convert it into microseconds. It is 20,000 microseconds. Now we will divide these 20,000 microseconds into 6. It is 333 microsecond. 3333.3 microsecond, but we will not consider 0.3. So 1t, that is this time, that will called time delay, this interval. From here to here, this t. In this session, we will utilize this time to generate signal. Let's build this project. I will use Arduino Uno and I am using 6 signals. One for high, low, high, low, high, low. I am connecting 330 ohm resistance . I connected 6 LEDs, each LED is in this way. I will connect first signal high to pin 2. We can use any digital I/O pin. This is low side signal, A high, A low, pin number 3. Here I will mention pin number 2, pin number 3, pin number 4, pin number 5, pin number 6, pin number 7. We will use these digital I/O pins. I will demonstrate how we can build this project. If you have some good idea that how to write this code, I will request you to send it to my email address. I will personally thankful for your contribution. Channel C high, it will go to pin number 6, and 7, that is low side signal, it will come here at pin number 7, and we will connect ground to these ground pins. Now let's write the code. Now I am opening Arduino Uno. And we will build this program like this. In the setup, here we will write pin mode 2, output. We need a standard delay, which we will define here, T, time delay. So we will create integer variable here, delay period, we can provide maximum 16,383 microsecond. So I will use this value. After that we will use this 3,333 microsecond, but at initial stage we will use 16,383. Let's create conditions here. In the initial step, we need to turn off all the signals low. In the setup, digital write, we can write a common code for all the pins at a time, but for best understanding I will define each pin alone. 2, low, so we turn off all the inputs low, 2, 3, 3 low, 4 low, 5 low, 6 low, 7. Before starting the code, we turned off all the inputs, that each output transistor must be off. No transistor will remain on. When the program will start, What is the condition of these outputs? Channel A high side active, B low side active, C high side active. Let's write here digital write number 2 high, number 5 high, then number 6 high. Here we will write comment A high, channel A high active. It is channel B low. B low is now active. This drive, this side transistor will on, and channel C high. C high is now active. After that, we will provide a delay time. To obtain 50 Hz signal, we calculated 3333 microseconds. But to visualize these signals, this time I will provide time delay in millisecond. I will write 1000 millisecond. After that we will convert it into microseconds. Delay period. This is our first time. At first time what will happen? This is our condition. Phase C high side will low and low side will active. Digital write channel number 6 low. Now it will turn off this drive. C high side will low now. In the same time, number 7 pin will active. 7 will high. C low side drive is now active. This is our first condition. Now move to second delay period. We will provide delay period here. We will copy these statements now. After this delay period, our B low number 5 will turn off. Number 5 will turn off, that is B low, low, B high, that is pin number 4 will active. Provide next delay and next routine, that is here. At this point, pin 2, digital IO pin number 2 will low, that is A high side drive, now it will become low. A low side drive, it will become active, that is pin number 3. After this condition, move to next position, that is this point. Number 7 will turn off now. Number 7, that is C low side drive, now low, and pin number 6 will active now. Phase C high side is now active, that is 240 degree. Then we will move to next step, that is this position. We will provide delay here. At this delay period, number 4 pin will low. Pin number 4 we turned on at this point, and now this will become low. B high side drive will become low and pin number 5 will high, that is B low drive. Then we will provide delay and next routine. Next step is here at 360 degree. Here pin number 3 will low, that is channel A low side, and we will remove this last routine. It will loop back to start up again. When it will loop back, it will write channel A high. Now I will send it to Arduino board. Yes. Okay, I will increase the delay time to monitor with this wave here 6000, so that we can compare easily. A high, B low, C high. Then it will change C side. Yes, C is now changed. Then B is changed, high. Then A will change here. Yes. Then C will change here. Yes. Then B will change here. Yes, now A will change here. Yes. So our phase sequence is now good. Now I will increase its frequency. 3, 3, 3, 3. And now we will change this delay period, this delay into microseconds. This microseconds, and we will change all the delays. Now it will provide 50 Hz frequency as we calculated here. And now we will check on oscilloscope. Yes, now we will verify phase A and phase B high side signals. Yes, that's perfect. We can see when this channel A is high and it is reaching to this portion, that is around 120 degree, that time channel B is starting. As we discussed here, after this time period, this signal is starting from 0, that is starting from 0 here. Now check to signal C. Yes, we can see when channel A is crossed from 0 and it is at negative side, then this signal C is starting. So we have exactly 120 degree phase difference in each phase. Now let's check high drive and low drive. This is channel A high drive, and we will check now low drive. This must be opposite to each other. Fantastic. We can see high side and low side are opposite to each other. Each phase have 120 degree phase difference. Phase A high and low have 180 degree. Now we have another agenda here, that when we use this drive push-pull, at that time we need that time between high side and low side, that when it is turning off, it is turning on. At that time, if there is no dead time, these will dissipate power. For that purpose, we will allocate dead time between these two positions, where when 2 is turning off, 3 is turning on, or 5 is turning off, 4 is turning on, at this junction we will provide delay period. We will allocate dead time. Integer dead time. This dead time is equal to, we will provide minimum 3 microseconds. Our first entry point, that is 6 and 7 number pins. We will copy this statement from here, copy, paste. We will copy this variable here, 6 and 7. This is our dead time now. copy, paste, copy, paste, copy, paste, copy, paste, copy, paste. We can see when A is turning off, A high is turning off, A low is turning on at the same time. But now we will provide time gap. Yes, that is this time. Before this, both channels were turning on and turning off at the same time. But now we have dead time. We can increase this dead time from here. If I will provide 5 microsecond or 10 microsecond, at that time it will provide gap between this signal high and low, so that crosstalk between two channels will not present there. It will not cause to heat up our drives. Yes, now we have 10 microsecond dead time. In upcoming session we will make it variable. Yes, channel B, channel C. Same here. Now I will provide 3 microsecond, that is 3 microsecond, that is good. Yes, we have this time gap. We have phase difference 120 degree, phase B, and here phase C. In upcoming session we will add some frequency adjustment in this project, and we will build this project using IPM, or we will use independent transistors, IGBTs, to take this signal high, low, high, low. If we need just only this signal high side and zero line, high side and zero line, we will use only upper side signals. But if we use UVW, high side, low side drives, at that time these signals are now present. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.